Everybody, welcome back again. Today we're going to talk about graphing data, and specifically we're going to look at one type of graph called the histogram. Okay, so once again, one of the major things that statistics is supposed to do is assess for patterns within a set of data. Okay, and one very easy way to start to assess for patterns is to do that with graphing the data. In other words, making some kind of chart or a graph that will show us what the data are kind of doing and behaving. And we'll see what that looks like here with the histogram. Now, there are lots of ways that you can graph data. You can use pie charts. You can use bar graphs. In fact, we'll use bar graphs later in this series, and lots of other things. But in statistics, what we use most of the time, certainly not all of the time, but most of the time, we like to use something called the histogram. It's very useful, and we'll see that, I hope, throughout the next several lectures. So the histogram, of course, is drawn along two axes, and most of your charts and graphs are going to be along these two axes. You probably remember this from junior high math kind of stuff, but let's quickly review that. So of course, the horizontal axis is referred to as the x-axis, okay? And then the vertical axis is called the y-axis. Now you always see the y-axis usually, well, I guess not always on the left side, although that's very typical. The x-axis, it could be on the right side if you're dealing with negative numbers, for example, then the y-axis is usually where x equals 0 is where that y-axis comes along. In any case, this is how we'll refer to these throughout the rest of the course, and this is universal as well. Everybody sees this. In fact, you may recall that if you have a three-dimensional graph, the line that would go this way, sort of depth-wise, is called the z-axis, but we'll never use that in this particular section. Okay, so the histogram, of course, looks like this, where you've got the value of a given variable, and I'll give you an example of this in a minute. The value of any given variable is on the x-axis. So it's like, what is the value of variable x, for example, along that x-axis? And then how many times that value occurs in the data set is shown by the y-axis. Now, of course, so far, this probably doesn't make a whole lot of sense, so I will give you a solid example, I think, right now. All right, let's imagine, for example, that you've got, you want to measure height in a large group of people. We'll say a group of high school students. You want to measure their height. And so you bring them into the basketball court. You bring, let's say, I don't know, a few, just over 100 people, and you say, all right, everybody, I need you to line up from shortest to tallest. And so they start to do that. Shortest people on this side, we'll call it the west side of the gym, and then the tallest people on the east side of the gym. And then some people will run into each other and go, wait a minute, we're the same height. What do we do now? And you say, oh, just line up behind each other then and sort of stack up, okay? And so that's what they do. And so what'll happen is it'll look something like this eventually, right? You'll have some people who are very, very short down here on the left. I'll do this. Very, very short people on the left, and there's probably somebody who's the shortest person in the entire sample that you have there. The shortest person's going to be right there, and then the tall people are going to line up over here, and you'd have somebody who's the tallest. It's very likely that there's somebody who's just a little bit taller than everybody else. But then, of course, most people fall closer to average, right? So just to pinpoint it, so let's say you've got average height, and we'll take like 5'8" or something. That's average height for a male. That's probably about right here. And you've got all of these people who are 5'8". They sort of stack on top of each other, right? All of these people are 5'8". And then all of these people are maybe 5'7" or so. These people are 5'6", and on, right? So you've got a lot of people who are roughly the same height, and then maybe you've got a 6'8" person in the sample who's over here, and maybe, I don't know, a 4 foot even person right there. Okay, so that's how a histogram works. It's very simple, very straightforward kind of stuff, is that you have people who kind of go like this. Now, what's important about a histogram is that you can start to assess for patterns in the data just visually. You can very quickly look at this and go, oh, so it seems like the average height is roughly there in the middle, and I can know what that value is by looking at the value that's given to me along the x-axis. So in a real histogram, you would have an actual height here, an actual height listed along these in these metrics here, right? So as you see, it takes on this nice shape also. This shape that kind of shows you this is often referred to as a bell-shaped curve or a normal curve, or in some cases you'll also see it referred to as a Gaussian distribution. That's just it's a fancy term. It's named after somebody who wrote a lot about this and discovered this, named Gauss, Gauss. In any case, that's a shape that we're generally sort of looking for. We often find that data in real life roughly follow this pattern. Usually not always and usually not perfect, but very roughly cover this pattern. So that's important because if that pattern occurs, that tells us a lot of information about our data set. And in fact, this should make a lot more sense as we continue to cover more examples in the next few lectures as well. So if I see this normal distribution, for example, what that tells me is there are very few short people, there are very few tall people, and most people roughly are average. And if I know this, I can now also tell you how much the average is. I could say the average height in this sample is 5'7" or whatever. I can also tell you, for example, how spread out the data are, and how, in other words, another way of saying that is how different people are from each other on average in terms of height. So these kinds of things can be very important, can give us very simple, straightforward data that we can start to make some practical use of. And it's a very, it's not even quite statistics because we haven't even run any numbers yet, but this is a nice way to start to understand what's going on with our data. Okay, so as I said, we usually do expect to see a normal distribution or a bell-shaped curve in the distribution, a Gaussian distribution, all meaning the same thing, or something very close to it. There are some other kinds of distributions that are more likely to occur. We're not really interested in something like a Pareto distribution. You don't need to worry about that for this particular thing, but that's a different kind of issue. So now, because we're usually looking for a normal distribution, we also need to come up with terms that tell us when it deviates from normal. We need to start to understand what's going on with the numbers that are underlying that data. And so that's the kind of thing that we're going to do next time. We're going to make these lectures very brief so that we can just pinpoint these principles. Okay, so we'll cover some of the terms that describe a deviation from normal distribution next time. Just a quick recap then of what we've done here is that graphing data is a very useful, very simple way to start to understand what are the underlying patterns within the data. Using a histogram, I can often tell you the rough approximate average and about how spread out those data are. Yeah, and so histograms are very useful for that kind of thing. A couple of points here are histograms are useless with categorical properties only. If your data have categorical properties only, there's no need to have a histogram. It doesn't make any sense. A histogram really needs not only ordinal properties, but it really should have interval properties to it. If not, it's really not appropriate probably for the data set. So histogram is appropriate for data that have interval properties or also ratio properties, which of course would also have interval properties if you saw the most recent lectures. Okay, and yeah, typically what we're looking for is a normal distribution, and oftentimes what our statistics will do is try to assess one part of statistics tries to tell if it's different from normal, meaningfully different from normal. And if that's true, then we have some other decisions to make. However, that's it for now. We'll talk about some of those terms next. I'll see you then.